All right, are you ready to rock? Ignite! Why don't you try?
Are you guys ready to rock? Awesome.
All right, that's better. All right, well, we're ready to rock. We brought our good hair and our rock band guitars. Now, you may be wondering, why are these goofballs on stage sporting great-looking mullets and wearing rock band guitars? Well, how many of you out there played Guitar Hero or Rock Band? Quite a bit of you. Now, Rock Band and Guitar Hero for gaming were great for folks that wanted to become rock stars in their own homes in a fairly short period of time. All right? They did this by simplifying the actions that you needed to take as a musician, limiting the number of buttons, limiting the number of strings on a guitar. Similarly, we would love to simplify the process of becoming a rock star at administering Azure Stack. My name's Charlie Satterfield. I'm joined here with Thomas Ruttinger. And today, we're going to talk about becoming a Microsoft Azure Stack infrastructure rockstar. Like any journey, it starts out with learning the basics. What's it made of? What's in the box? How do I control it? How do I monitor and view health? Once you understand the basics, you start to put a few chords together. How do you think about automating tasks? How should you think about integrating this into your data center and your existing data center systems? Next, much like Rock Band, as soon as you put a few chords together, you're eager to get ready to jam. And today we'll walk you through an end-to-end operation scenario. After that, you're probably wondering, where's my next gig? What are the resources and education I need to put in front of me so that I can make that journey to rockstar status? And then lastly, we'd love to take your questions down here at the stage afterwards. Let's start our journey. I see a room full of talented engineers, all with varied skill sets and areas of specialization. You're probably wondering, how do I apply those, and how do I move forward into this thing called cloud administration? Let's start looking at the toolbox that you use today. It's full of different UIs and APIs, from Hyper-V Manager and Failover Cluster Manager to Virtual Machine Manager, SCOM, DPM, SMA, PowerShell. The list goes on. It's not exactly a very efficient way to do cloud administration. But varied UIs and APIs are not the only challenge to making cloud administration more simple and more efficient. In today's organizations, there's many silos of technology responsibility. Why is this? Well, we require a large amount of deep knowledge in many of those silos in order to effectively run a private cloud in your organization. And as a result, it's rare for these private clouds to be run by a single administrator. It's just too challenging. So how do we approach this problem? How do we make cloud administration much more efficient for you with Azure Stack? Well, it starts with a vision. And our vision is that cloud admins should be able to operate and troubleshoot across the infrastructure of Azure Stack. We should provide a single point of UI and APIs that allow you to operate and automate your tasks. We'll offer fewer knobs, so it's much easier for you to come up to speed on the technology and to operate that technology. And it can be managed by a single admin. And the value to the business in this is in the service SLA, not in managing the underlying infrastructure. It's those top-of-stack services that you're offering to your tenants or your business organizations. That's where you want your focus. So let's see what's in the box. We launched TP2 on Monday. It's available for download for a single box proof of concept evaluation. Let's talk about what's in that box, how you control it, and how you monitor it. Azure Stack architecture, as we talk about it, consists of 4 different layers. We have the ARM layer, where the Azure portal and the Azure Resource Manager exist. We have the RP layer, which provides that northbound REST API interface for both tenant services, as well as the foundational RPs that we've built in order for you to manage Azure Stack. Supporting those foundational RPs is a layer of infrastructure roles, the infrastructure control layer. Now, there are many of these roles that support and actually perform the tasks offered up by those REST APIs by the RPs. But you can think of these roles as services that you may see if you were to open up Task Manager in Windows. You don't need to worry about every one of them. And we may ask you to start and restart one every now and again. But for the most part, the system will take care of those. And then lastly is the hardware layer. Your network switches and your servers, which offer up the compute and storage for Azure Stack. Thomas, would you mind taking us through some of the new RPs and controllers that we've built especially for these folks to be able to easily manage Azure Stack?
I will. Great. Thanks, Charlie. So I want to draw your attention to start with the orange boxes in the resource RP layer. SRP, CRP, and RP. Those have been resource providers that you have already been seen in Technical Preview 1. So in order to enable that seamless, unified administration experience, we're going to introduce 3 additional resource providers. So you've seen that slide, hopefully before this week, and you potentially wondered, what does FRP, HRP, and URP stand for? What are those resource providers do for you? So FRP will provide the management capabilities for the underlying infrastructure components. We have a health resource provider that allows you to retrieve health. And we have an update resource provider in order to manage updates for the entire Azure Stack appliance. Now, drilling in here, what is a resource provider? As a quick recap, it's going to enable the communication with the underlying infrastructure roles and the hardware layer. They are implemented as microservices running on a service fabric ring. From a security perspective, it is important to understand that you can only interact with those resource providers with the admin subscription. Now, what is common across those resource providers? They all provide a northbound API that can be consumed by various tooling sets like Visual Studio, PowerShell, Azure CLI, but of course, through our portal. The southbound API does communicate with the underlying controllers. And the underlying controllers really orchestrate and give you the ability to provide that new management experience where you no longer have to flip between the different management tools. For the developers, Health RP and Update RP have a unique registration API that allows you, when deploying additional services on top of Azure Stack through ARM templates, that they can register with our health system as well, so that resources attached to a resource provider can report their health and light them up in Azure Stack as well. Now let's take a look at an example. So now imagine you're using our UX and you want to retrieve infrastructure virtual machines. So how does that look like? So FRP calls down into what we call the compute controller, and compute controller calls into the OS layer and interacts with Windows Server, and particularly either with failover clustering or Hyper-V to return you the list of infrastructure virtual machines. That is a high-level example, and I want to drill in the individual controllers to give you an understanding. What are the controllers? What are the responsibilities of those controllers? And we're going to start with managing the physical node. So the physical node management controller interacts with the baseboard management controller in a server. Examples for a baseboard management controller are HP ILO, Dell iDRAC, just to call out the examples. So we're going to use what we call a PCSV device implementation. It's leveraging the IPMI protocol to interact with the physical server. What it does allow us to do is it allows us to power on a server, power off a server. Why is that so important? You want to be in a position to recover a server at any given point in time. You want to be in control of that physical server. It removes the need of browsing individual baseboard management controller websites and interact, so you can do it straight through one interface. Charlie mentioned the infrastructure roles that do exist in Azure Stack. So we're leveraging multiple platforms: Service Fabric, failover clustering, Windows Server, IaaS, multiple technologies. So what the infrastructure controller does is really managing the entire life cycle of those infrastructure roles. Starting, stopping those services, scaling them out, patch and upgrade them. So it's really all about the entire lifecycle management of the underlying roles based on their individual hosting platform. Compute controller. Compute controller is not only leveraged by the infrastructure, it's also used by the compute resource provider. So it's not only a component leveraged by the infrastructure, it's also used when you're going to, for example, deploy a ARM-based template. So it's also going to call into compute controller. Compute controller really provides you the ability, it looks into VM placement, determining the best host for placement of VMs. It's executing the VM actions. It's creating configurations, updating configurations. As a summary, it's managing the entire lifecycle of virtual machine objects. Storage controller. Storage controller does allow us to manage pools, volumes, file shares that do exist on the underlying storage technology. Scale-out file server with Spaces Direct in our first release. Now, let's take a look at how does this look end-to-end and what are additional functionalities when thinking about hardware management. So I talked about the physical node management. It's going to leverage IPMI to talk to the baseboard management controller. But it's also about security. So when it comes to auditing, so what we enable out of the box is radius authentication for physical network switches. That really gives you the possibility to really identify who authenticated on a switch. Was it successful? Did it fail? In addition, the same applies to the baseboard management controller. We do support LDAP here, but also radius in addition. Retrieving hardware-related health information is handled by out-of-band management tools. I heard that question a couple of times this week over in our booth. Do we allow to place any monitoring agents? The answer is no. It's all based and information coming through the baseboard management controller using IPMI. With that, Charlie, would you mind walking us through the monitoring
Sure.
details?
Thank you, Thomas. Switch over here. So along with what's in the box, you want to understand the health of your system. Actually, sorry, jumped the gun. Let's talk a little bit about the problem space first. Azure Stack and other private clouds are complex systems. There's many challenges that comes with monitoring a complex system. We focused on two particular problem points that we wanted to address as we designed a monitoring solution for Azure Stack. The first is the complexity of understanding health. Clouds depend on many different technologies. The health of the cloud is not always the sum of its parts, and it's difficult sometimes to correlate the health of an underlying component and how that affects the service that you're actually providing your end tenants. And lastly, how do alerts relate to health? Often in some monitoring solutions, you may have alerts that fire and don't change health state. You may have health states that change and you don't get an alert. That's kind of confusing for an administrator. The other problem we wanted to address was the tax of alert deciphering. Oftentimes, you may be flooded with alerts, and it's difficult to determine which alerts do I need to take action on, which one do I need to address first, and what are the right steps to go ahead and resolve. Now, even if you're not in the business of monitoring today, you may be familiar with this just from owning a smartphone. I'm sure a lot of you are on planes this week coming to Ignite, and the moment you turn that phone back on or disabled airplane mode, you may have been hit with a barrage of notifications, and it probably took you a while to get through that and realize there wasn't one that was even important. So why did I get all those? I know I did. So we set out some core principles as we looked to design the monitoring solution for Azure Stack. The first was that health should be very simple to understand. So we've directly linked health state to the presence or absence of an alert. If there's no alerts for a given component, that component will be healthy. If there's one or more warning alerts, we'll be marking the health state of that component to be in a warning state, and likewise for critical alerts. We've eliminated the concept of health state rollups. Oftentimes, the rules involved in some of these rollups can mask issues or present an issue when there really isn't one. And then lastly, we're separating the health of cloud services from the underlying infrastructure. We want to be able to present a health state for that service that you're providing to your end user or your tenants, in addition to any health state for that underlying server or infrastructure role. Our next principle is that all alerts should be actionable. We're only reporting alerts against well-known objects, and we're working with our component teams to make sure that we have a very consistent severity definition. I'm sure some of you in the room may have been woken up in the middle of the night for an alert that really wasn't something you should have been woken up for. So we're making sure that all critical alerts are the ones that you would want to be woken up for at 3 a.m. The rest of those alerts, those will be warning severity. And we've eliminated the concept of an informational alert. Our monitoring solution should be focused on the action that you need to take to remediate an issue, not for just random information. We're working again with those teams to make sure in the TP3 and GA timeframes that we've got clear descriptions of the problems and the remediation steps required, as well as links to online troubleshooting guides for those problems that may require a few extra steps. So how does the monitoring solution work? Well, it all begins with the HRP, the Health RP. It exposes a northbound REST API up through ARM, and it allows for registration for resource providers and infrastructure roles. That's stored by the health service in our registration data store, which all sits in a service fabric ring with the rest of the foundational RPs. In return, the Health RP returns via REST API health state and alerts for those components, Those components exist in those 4 layers that we've talked about, and each of the infrastructure VMs and hosts within those roles has the Azure monitoring agent present. This is the same monitoring agent we're using in Azure Public to stream events to a central monitoring location to raise alerts so that our engineers can take action. Similarly, we're using that agent in Azure Stack to forward ETW events to a storage account, individual storage accounts that are associated with each of the ERPs that have registered with HRP. Any event that is meant to raise an alert is sent to a specific container within that storage account called the fault container. Our alert service is monitoring each of the fault containers and each of the storage accounts that have been registered, and as soon as it detects the presence of an event, it raises an associated alert for that event. That alert is then present via the REST API in the Azure portal, as well as any external system you may have connected. So let's look at it in action quickly. Oops, sorry. One more slide. Forgot about that. What we've talked about so far is the software monitoring aspects of Azure Stack. As admins, you also care about the hardware monitoring of Azure Stack, I would assume. We provide native support for physical disk, network adapter, and node alerts within Azure Stack, within our Health RP. For low-level device information and alerts, we're relying on our hardware partners that are shipping Azure Stack solutions to provide agentless monitoring solutions via their baseboard management controllers. And likewise, the network switches will need to be monitored via external monitoring solutions via SNMP. However, you can connect up the health alerts from the HRP via the REST API. They're available for consumption in those external systems as well. Finally, let's look at it in action. Now in TP2, the monitoring pipeline exists. It's part of the package. It's in the box. We have some alert content that is enabled. There's much more alert content that's coming in future releases. One of the scenarios that we wanted to enable in TP2 was to make sure if an infrastructure VM that supports Azure Stack went offline, that you knew about it. You could see an alert associated with that. So I'm logged into the Azure Stack portal. I'm logged in as an account that is part of the admin subscription. So I get to see a tile called Region Management. Now the Region Management tile presents a list of regions. There's only going to be one in the TP2 proof of concept that you install, and the counts of critical and warning alerts for that region. If I were to select the local region, I enter into a blade focused on region management that presents me with an alerts tile, and then a list of resource providers and infrastructure roles that have been registered with the Health RP. If you look, we do have a health state next to the health controller. We're one of the few infrastructure roles in TP2 that's hooked in alert content into the alerting subsystem. And so our health state is currently healthy. We don't have any alerts. However, I do have an alert that's in a warning state. So let me dive into the list of alerts and see what might be happening with my system. Now, I see I just have the one alert. It's warning. I can go in and see the details of that alert. And it's telling me that the infrastructure role instance, MAS-SUS01, is offline or unreachable. And in the description and remediation, it's telling me that the machine may be offline or there might be a networking issue preventing communication. So it's recommending failover cluster or Hyper-V manager to take a look at what's going on. So let me go ahead and take a look. I could have sworn they were all up and running earlier, but no, actually, someone must have turned this off.
It wasn't me.
Yeah. So as soon as one of these infrastructure role instances goes unavailable from either network issues or the machine went offline, we have a heartbeat from that Azure monitoring agent. And it occurs every minute. And after 3 instances of that heartbeat not occurring, we'll raise the alert that we saw in the Azure portal. So let me go ahead and click Start and start succeeding. So just as it took a few moments to raise an alert for that machine, it'll take a couple minutes, and that alert actually will resolve itself. And so it will no longer be in the list. You can still get to the alert by unfiltering the list view to show both active and closed alerts, but there won't be any active alerts. So with that, Thomas, do you want to show us how to put a few chords together?
Absolutely. So you're still with us? Great. So we have taken a look at what's in the box. What is the next step? Thinking about automation and integration. Looking at those APIs that do enable rich integration, either with monitoring systems or looking at the infrastructure side and thinking about integration with control planes. If you already investigated in putting your own infrastructure control plane together, that's what you were interested in to understand the API integration. So let's start by taking a look at the principles. Your first step when interacting with APIs is doing an authentication request to Azure Active Directory. Stay tuned there. It's not going to be only Azure Active Directory, but that's where we are with Technical Preview 2. Once we authenticate it, we're going to call ARM to retrieve a token. With a token, we can call the underlying resource provider, either FRP, HRP, or URP. So in that example that I put up here on the slide, we're going to call a namespace called Microsoft Infrastructure Insight.admin. That's the health resource provider namespace. So that call, as I talked earlier, will go down to the underlying controller. And if there is an alert, we're going to retrieve that alert. In fact, it comes out of table storage, because that's where the Azure Monitoring Agent is going to store the event alerts. And the alert gets presented to the tool of your choice. Those are the principles. Let's do a click deeper into the individual namespaces and the resources available in those namespaces. Again, common across all the 3 RPs, everybody will give you a location. A location is a region. So as we talked about Azure Stack, what you already know is we're going to support multiple regions. Azure Stack will support multiple regions. It's going to represent infrastructure roles, logical networks, storage subsystems, file shares, role instances, scale units, and as a nested object of scale units, physical servers. This is a sneak peek. This is where we are with Technical Preview 2. What are the actions I can do against those resources? We focused on read only. That's why the action are get calls. Looking at the health resource provider, again, locations, I can retrieve alerts, and I can do registration. What's unique to the health resource provider is I can also do put requests. Why is that helpful? Because I want to be able to close an alert. And I can also delete the registration in case the deployment failed. The update resource provider, location, region update status, the update itself, and the update runs associated with individual updates. Now, Let's take a look at a demo. So we're starting off, again, by looking at the UX. What I want you to memorize is, again, we called it out earlier, it's a single region. I drill into that region one more time. So everything that you see in that region, in those blades, the information is going to be queried through the APIs. So now let me flip over, and let's take a closer look into APIs. So it all starts with the 3 principles. First, we're going to store credentials. So we authenticate against Azure Active Directory. Once we have authenticated, we're going to do get Azure Stack token to get a token from ARM. And once we have a token, we can call the underlying resource provider. So let's take a look here. So you should see an authentication popping up. Great, so we retrieved the token. So now it's time to do some calls here. Let's start by something simple. Let's call FRP to retrieve the region. Let's take a quick look at one of those calls. Subscription ID. Again, I said that in the beginning. You can only call from the admin subscription. So it's going to be the admin subscription ID. We specify the namespace that we want to call, Microsoft.fabric.admin. That's for FRP. And last but not least, we're specifying the method. So I'm using PowerShell here to invoke a REST call to FRP. So let's take a look. Great, so we retrieved the region, local. That's consistent with the UX. Let me show you one more that is consistent with what you already see today in Technical Preview 2 with the UX. We're calling to query all the infrastructure roles. Now here's the entire list of infrastructure roles that do exist in Technical Preview 2. Now what about calling an object that is not displayed in the UX? Let's call the storage subsystem. Let's see what we can retrieve and learn about our storage subsystem. Let's take a closer look at the response, at the return response. So we retrieve the name of the storage subsystem, and we retrieve properties. So what we learned, total capacity available in that system is 3763 gigabyte available storage space. Let's take another call. Let's take a look at scale units. So what we return is, and Spencer may hate me for using the word, we're retrieving the underlying cluster object that is part of the scale unit. So what we see is basically the cluster name. We have additional properties attached to the cluster objects, like what is the cluster type. One, in that case, is a hyperconverged. We see the state. It's online. We learn about fault domains, just to call out some examples. And the last call I'm showing you for information that is not in the UX is what is the physical server. So what this demo showed you here is like it's running a one-node installation, single cluster. It's exactly what you can deploy in your data center today and get started. Now, let's move from Fabric into the Health RP. So let me quickly flip back into the portal. Because we knew we had one alert. Let's do a quick refresh. By now, we hopefully see no alerts, because Charlie remediated the issue. He turned on the VM again. Let's wait a minute here. That is a different virtual machine, Charlie.
I don't know. Sometimes I just like turning off VMs and making sure that it still runs.
Thank you. Let's take a look if we can retrieve that alert through the API. Let's first query for all alerts. That's a lot of alerts. Let's filter them for active alerts. Yep, CA01. So what about closing the alert? Well, let's take a look if we can do that in the portal. Let's select the alert. There's no action. So let's try if we can close it through the API. Okay, let's flip back to the portal, let's reload the portal. We close the alert through the API.
But you didn't fix the issue.
I didn't fix the issue. I just closed the alert. I don't think that's important. So let's see.
Well, if it's running, maybe it's not.
Let me do a quick last demo of the update RP. So we see the current version of this Azure Stack deployment is 2.0.0.1. And we know there is an update available. Let's take a quick look. Yeah, there's an update available. And it will patch it will patch Azure Stack to version 2.0.0.3, and I'll also see that I had some additional update runs in the past. Well, while I can select the update and can do that through the UX, I'm going to do this through PowerShell, calling the REST API. So I first queried the updates. Take a quick look if that is consistent. It's applicable, yes. The update version 2.0.0.3. So let's apply the update. Well, I guess we're going to skip that part. Well, given that we're still having another tool available, right? So what we're going to do is, it's a good point, actually. Let me try the first one in the array before we move on. Unfortunately not. We blame Justin for this. All right. Now, if you feel working with REST is not what you want to do, and you're interested in using traditional PowerShell, what we're going to make available shortly after the conference is a PowerShell module, what is literally a REST wrapper around the API that will allow you to do exactly the commands that I showed you. For example, returning get Azure Stack infra VM. We're passing on credential object and specifying the admin ID. And it will return you all the infrastructure VMs. I quickly show you what is in that module today, what are the functions that existed today. There is a couple of subset that is available there today. As I said, I'm going to make it available on GitHub for you to get started. With that, let's flip back to the presentation. Now, how do I integrate Azure Stack systems in a data center? Now, we made a lot of learnings with our Cloud Platform System Premium. And I'm listing out here integration touch points that you need to think about when it comes to integration. IP space planning, what are the required IP spaces that you require? How do I configure the physical network configuration uplink to my border devices? Do I require long-range modules? Do I require short-range modules? What are those requirements there? How do I integrate with my Active Directory? How can I enable my existing users to authenticate on that Azure Stack portal? Syslog servers for network devices, time servers in your environment. What are the firewall rules that I have to configure to publish VIPs? How do I configure DNS resolution? Am I doing conditional forwarding? Am I doing stop zones? Maybe I'm super large and using root hints. What about SSL certificates? What about my monitoring integration? So those are all just starting points that you need to think and start planning in advance to really integrate a system in your data center. Those are learnings that we have made by integrating Cloud Platform System Premium with customer data centers. Now, I pulled out some areas that I want to make sure we're drawing attention to because, again, based on lessons learned, those required the most time and complexity to get that set up. One is planning the required IP network space. What are the networks, and that's important for your network administrators, what are a network space that has to be routable outside of Azure Stack? Because that network space cannot overlap with your existing IP space. What networks do only live inside Azure Stack? Those are all questions that you have to think about. Now, how do I integrate with my border switches? You see one topology here with top-of-rack switches. That can also be a topology with aggregation switches once you scale out, potentially even cross-physical racks. So we're following an RFC here that describes the layer 3 point-to-point connection. And the routing protocols that we use to announce routes up to your devices is BGP, but we also can do static routing. Static routing obviously leads to more work and more changes on your side because it isn't obviously dynamic. That may have hurt. And again, aside from routing, you also have to think about the physical connectivity. What kind of modules do I need? Long range, short range. Those are the things to consider. Now, wouldn't it be great if you can use your existing user identities and log on to Azure Stack for troubleshooting purposes, or enable them for device authentication? As is pointed out earlier, Azure Stack does come with Radius. We do have pre-created groups where you just move your existing users in to grant access. That's the purpose when we think about Active Directory integration. So, some quick facts about the directory that comes with Azure Stack. No matter how many regions you're going to run of Azure Stack, if it's an instance with multiple regions, it's going to be one Active Directory forest. It's one root domain. We're going to do an AD site per region. And we do minimum 2 domain controllers per scale unit. This is where it gets important to enable your existing users to authenticate and work with the portal. And again, what I have to say up front, what you see here on screen right now is what you have in Technical Preview 2, leveraging Azure Active Directory. What's in the box: portal extensions, ARM, RPs. They're communicating with the Azure Active Directory graph service that does enable the RBAC scenarios, and Azure Active Directory communicating with the Microsoft Online Directory service. That's what you have today. Giving you a sneak peek, what's coming beyond Technical Preview 2 is enabling using your existing Active Directory users to authenticate on the portal by using Active Directory Federation services. Now you may say, ADFS is already there. What's the work that has to happen there? So the work that we're doing is refactoring the Azure Active Directory graph service to work with Azure, with Active Directory on-premise, to enable RBAC even with ADFS. And that leads to, once that is in place, all you have to do from an integration touch point is you're going to spin up an ADFS federation between your existing ADFS and ADFS that comes with Azure Stack. Now, let's get ready to jam.
All right. Thank you, Thomas. So as we mentioned, we've learned what's in the box. We've started to learn about the APIs and the integration points. Once you have this and you're ready for production, you need to worry about that end-to-end operation scenario of, I get an alert, what happens? We want to enable you to use your existing monitoring solutions and ITSM pipeline to monitor Azure Stack for the software, as well as the solutions provided by your partner, your hardware vendor, for the physical server, and then any solution you have in-house for those network devices to flow to your monitoring solution and likewise to your ticketing and CMDB. That one's yours. Let's take a look at what that might look like in your data center. All right. Let's go back to our main screen. I thought you closed that alert.
Yeah, I thought so too. Did we close the alert?
All right, well, I guess we didn't fix that problem. So the alert reappeared because we still didn't get a heartbeat. So unless I was watching the portal, I wouldn't have seen that. So Thomas, do you have anything that we can use that would light up something to our either ticketing system or inbox?
I guess I may have a solution for that.
Okay. Show me what it is.
So let me start by taking a look at my inbox. So yeah, indeed, I received an alert.
How'd you do that?
Well, we're going to use an integration between Azure Stack and Nagios. So we have partnered with our partner Cloudbase to create a Nagios plugin using Python to retrieve alerts from the Azure Stack API. That plugin is available today for download, and you can start using it for your Technical Preview 2 deployment. So let's take a look at that. So I'm going to start by showing you Nagios Core Edition. So we see Azure Stack instance is registered, and we see a warning for a service. Let's drill in. So we're retrieving the same severity, a warning. We're going to retrieve the alert ID. What's the namespace, the source, the title, and the description, and the remediation steps. That's exactly what you have seen earlier in the API. So that information comes straight from the API. So the API is the single source of truth. No matter if you're going to use the Azure Stack portal, API, PowerShell, or external monitoring tool, they all show the same information. And you can retrieve them, in that case, through Nagios. Now, let me see if I can close that alert. So what I'm going to do for that is I'm going to send a custom notification. And there's a handler running in the background. I apologize. I first have to take the alert ID, because that is what's required to identify the unique alert. And I'm going to send a custom service notification. And all I'm doing is /close-alert. Flip back to our portal, and let's validate if the alert got closed. So you see we have closed the active alert through an external monitoring system, in that case Nagios, leveraging the APIs and closing the alert in Azure Stack. So that way we can enable bidirectional communications between your monitoring system that we want to integrate Azure Stack with, and you can continue to use existing workflow pipes. What we mean by that, if you have interconnected your monitoring system with ticketing systems, we can leverage those existing pipes. There is no need to recreate or build any automation to have alerts come in to interact with your ticketing system, so we're just using your existing workflow pipes. All you have to do is to integrate with the monitoring system. Now, that alert will obviously come back because we didn't remediate.
We didn't remediate.
Right? So
why don't you turn that back on so that we don't get any more alerts today?
I will do that. Stay here. So, can you stay on the demo?
Okay, sure.
As I said, the plugin is available for download. It's on the Exchange Nagios org website, the directory for open source plugins. I want to quickly show you how we integrated that. In that case, we just added an additional VM that runs Nagios for simplicity. But you can also obviously leverage existing Nagios deployments when you spin up a VPN tunnel to your Azure Stack deployment to interact with the API. We're going to publish soon a document as well where we're going to list the steps that are required if you just want to run it all in box so that you can retry that yourself. All right, that's it for the demo.
Thank you, Thomas. So as Thomas just demonstrated, we have a solution already with TP2 to plug in at least one monitoring solution, this being Nagios. It's available today. You don't have to remember the long URL that was on the screen. We have a short URL for you here, which is aka.ms/MAS Nagios. We will also soon have API examples and documentation for you to be able to build custom integration. And in future releases, we will also have a management pack so that your existing SCOM deployments can also retrieve alerts from Azure Stack to fill your existing pipelines. As we mentioned earlier, the physical server monitoring will take place via the baseboard management controller. You can use System Center Operations Manager or other OEM-supported monitoring solutions for that agentless monitoring, network devices via SNMP, and then everything we've talked about today is mainly, or it has been, infrastructure alerts, nothing about the tenant. However, you can leverage the existing Azure Management Pack for SCOM to be able to manage or to be able to monitor your tenant subscriptions, as well as use OMS. So this is just the beginning of the journey. Today we reviewed the admin UI. We talked some about monitoring. Thomas demonstrated the APIs as well as the data center integration. But we have much more to come. We have software updating for the Azure Stack software, the device drivers and firmware. We have our business continuity and disaster recovery story. We have much more in monitoring content to bring you. We have administrative actions beyond just read-only. We'll talk some about field replaceable unit strategy in the months to come. And then many more APIs that aren't available just yet. So where is your next gig? What's the information available for you today? We've announced this week free IT Pro resources to advance your career in cloud technology. A lot of these right now are focused mainly on Azure and how to administrate Azure, but to expect some to come shortly around Azure Stack administration. This slide will be available in the deck online so that you can visit each of these links. We also have upcoming cloud role training, specifically around cloud administrator and cloud architect roles. Expect in-depth training to be available in 2017. We welcome you to start your journey with Azure Stack TP2. Download the bits, install them on your own server to find and explore what's in that box, how you control it, plug in our monitoring into your existing data center solutions, and then start building automation against the APIs that exist in TP2. For those of you staying beyond today, we have 3 more Azure Stack sessions tomorrow. We have a session to learn about the community of templates for Azure Stack. We have a Microsoft DevOps on Azure Stack session. And then lastly, learn more about hybrid applications with Azure and Azure Stack. Welcome you to attend these sessions. There's lots of great information that will be presented. Please remember to fill out an evaluation. We've got a healthy competition against most of our teammates. I know VJ and Spencer are competing against each other, but we'd really like to just trounce both of them. So please fill out an evaluation. And lastly, if you'd like to participate in the conversation more about Azure Stack, please follow us on Twitter. We'll have more information over the coming months, and we'll reach out to engage with the administrative role and all our engineers in this room. Thank you very much. Enjoy the rest of the conference.
Thank you, everybody.